just before I get onto this conical pendulum business, I want to comment very briefly on this astronaut, okay? So I'm not going to give a full explanation, but I think the hardest part about this for me when I was doing this question was just to wrap my head around like, what on earth is going on? And then the maths kind of sorts itself, like the manipulation, the calculus sorts itself out, okay? So here is the picture. Just put your pendulum down for a moment, okay? Here is, here's a flight simulator, okay? What they've got, I think their picture says, an astronaut's in a mechanical flight simulator moving with uniform circular motion in a vertical circle. And by the way, it's really hard to do this like just with words. When they say vertical circle, a circle obviously occupies a plane, right? So when you say vertical, it's just an axis, right? What they mean is the plane facing up, down like this, or is it like that, right? There is still, like if I show you this plane, clearly there's a horizontal dimension here. Like duh, like it's right there, okay? But when they say vertical, what they mean is like, you know, standing up. So that's why I've got this picture. So you've got the astronaut, right? And the astronaut is going around and around and around, like so, okay? And they say, let's read the rest of the words. What angular velocity is required to cause the astronaut to feel weightless during the instant at the top of the vertical circle? Okay, now there's a whole bunch of series of things that are confusing about this, okay? For starters, what does weightless even mean? Like, what's going on here? They realize that's a bit confusing, so they clue you in. They say, at the top of the circle, so here's the origin. Here's the astronaut at the top of the circle, okay? And they're saying, yeah, at this particular point, they are not experiencing any weight, okay? Now, the question is, why? Okay, and then that sort of guides the mathematics. Okay? Now, for starters, we can say, look, obviously, wherever this astronaut is on this flight simulator, on this circle, they are always experiencing a weight force that is pointing downwards because they're on the Earth, right? So it's like here, it's going down that way. Here, it's going right down along the radius. That's really important. I think it's really, really important. And the other thing I want you to note is that because they're like experiencing this downwards, right? To be weightless is to not feel that anymore, okay? To not experience this force, okay? Now, let's just think about this, right? If you were weightless, you're sort of, I put an object, I put it in the air, right? It's suspended somewhere, right? And it didn't have any weight. How much weight force is it going to experience? Zero, right? Or I should say if it has no mass, therefore it experiences no weight force. So it's going to stay still. Okay, does that make sense? It won't move. Why is that? Why is it not moving? Which law does this talk about? This is Newton's first law. It's experiencing no forces, so it's stationary. It could be moving in uniform straight line motion as well, but at the moment it's just staying put, okay? So the corollary of that, thinking about that from the other way around is, if therefore I want to experience myself being weightless, not having any weight, not having the weight force pulling me in a particular direction, right? Therefore what I need is to have a net force of zero, right? That's what I want, okay? If net force is zero, then I'm not going to feel like I have weight, okay? Now look at the diagram. Where's my green? It's green gone. Oh, here it is, okay? Look at my diagram. You got weight force going this way. So therefore, in order to counteract this force, there must be a force going off in the direction of the normal, right? But this is confusing to me because if there's one thing we know about uniform circular motion, it's that when you're moving in a circle, there's a force acting on you in which direction? Towards the center. So why is this going off in this direction? Maybe you want to label some things for me here, right? This is the weight force, so it's mg, right? mg going that way. And then you've got this guy. Now, why is that there? I will tell you why it's there. This is all about, the hardest part of this is it's about what the astronaut is experiencing. There is a force going out in that direction, but only because it's about the astronaut's experience, not because of what's physically going on, okay? Physically, the only force that's, only two forces that are being experienced here are the weight force, and physically, there is a force going towards the center wherever they are because they're attached to this flight simulator, right? So that's why they're not flying off into, off into the space, right? Well, actually, Earth, because they're on Earth, it's a simulator, okay? But I want you to remember, when we were going through uniform circular motion, we resolved all the horizontal vertical forces, and we saw, oh, okay, this is the normal force. And then I said, hey, what about this guy? What about along the tangent? Okay, what force is being experienced there? Zero force, okay? This tangent is important because the tangent is the astronaut's point of view, right? It's what the astronaut is experiencing. They're always there along that tangent, experiencing reality along this tangent, right? It's like, here's forward for me, and that keeps on moving and moving and moving, okay? So therefore, what the astronaut's going to experience is, remember, he's going around here, and from the perspective of the tangent, he's not moving from the perspective of the tangent, right? So therefore, if he's not moving, there must be balanced forces, right? There must be net force 0, okay? So what this means is that there's this force towards the center, the centrifugal force, okay? But there's this, and it's literally called a fictitious force. This is the actual technical name. It's not really a force. It's a force that the astronaut experiences because from his point of view, he's not moving. It's an inertial frame of reference, okay? So seeing as he feels like he's not moving, right, he experiences a force that way, which is why if you're on a roller coaster, you feel like you're being thrown out towards the edge of the thing. You're not. The roller coaster is holding you in. That's why you're not actually flying off, okay? But you feel a force. Okay? And that's what that feeling of weightness comes from. This fictitious force, if it exactly balances with the weight force, then they cancel out, and therefore there's a net force of 0. Okay? Now, because this force toward the center is called a centrifugal force, I think it's a T. Might be an A, not sure. This centrifugal force is going towards the center. It's the real force. But this fictitious force up here, what's felt, is called a centrifugal force. Okay? It's not actually a force in the way that gravity is a force, but it's what you experience. It's what clothes in a washing machine experience when they get flung towards the outside. Okay? So this force is what balances with the weight force. Okay? And so you've got to work out a speed that will make these exactly the same in terms of gravity and all that kind of thing. Okay?